Fusion Mobile, quality e-learning experience on the go.
Good day. You are welcome to Fusion Mobile e-learning class. My name is Bolaji. I'm here to teach mathematics as a subject, and the topic is probability. In probability, we are going to consider experimental outcome. Number 2, random experiment. Number 3, event space, sample space. Then the definition of probability. In probability 1, we are going to consider all this terminology in probability. Now, what is experimental outcome? Experimental outcome. Experimental outcome is therefore the number of trial carried out. The numbers of trial carried out. The numbers of trial means experiment. Number of experiments carried out. It means number of required outcome over number of possible outcome. That is, number of required outcome over number of possible outcome. So experimental outcome means number of required outcome over number of possible outcome, which I have said earlier on is number of trials. Number of trials that is carried out, that is called experimental outcome. Now, I want to show us an example that explains experimental outcome. Consider the table below that shows the mark score of a student in a mathematics test. Example 1. Consider the table below. This is the mark. This is the number of students. Now, the mark score by this student, we have 30, 40, 50, 60, and 80, which are in percentage. The number of students that scored 30 is 11. Number of students that scored 40 is 8. Number of students that scored 50 is 4. Number of students that scored 60 is 5. And number of students that scored 80 is 2. Now, this is the table we consider, which have shows the mark of the student and the number of the student. Question 1 from this table: how many students took the maths test? Number 2, B part. The B part of this question is, what is the probability that a student choosing at random from the class will score 40%? What is the probability that the student choosing from random will score 40%, 2, above 50%, 3, below 60%. I want us to consider these two questions because it's a form of experimental outcomes whereby we set a maths test between numbers of students, and the mark scores have been displayed on the table. So this is an example of experiment, that is numbers of trial that was being carried out. Now, how many students took the mathematics test, and how many of them score 30%, 40%, and below 60%? Now, I want us to look at this. The numbers of students that took the test is equal to 11 plus 8 plus 4 plus 5 plus 2. 11 plus 8 will give us 19 plus 9 plus 2. That is 18. That is 19 plus 11. 19 plus 11, that's 0, 30. So now, the answer is equal to 30 students. 30 students took the mathematics test from our experiment. Then what is the probability that the student choosing at random will score 40%? Number of students that will score 40% is equal to, that is, we have 8, which means 8 students score 40%. Therefore, 8 over 30 is equal to the number of students that will score 40%. That is, we have 8 students that score 40%, and the total number of students is 30 students. That is number of required outcome, which is 8, over number of possible outcome, which is equal to 8 over 30. 2 year for 2 year, 15. So the probability that a student will score 40% is equal to 4 over 15. Is equal to 4 over 15. I'd like us to still continue by looking at what is the probability of students that will score above 50%. Number of students that will score above 50%. Now, I want us to see this table, that this is 50%, above 50%, that is number of students that will score above 50%. Here, this is 60, 80. The number of students that will score above, number of students that will score above 50% is equal to, look at our table, 5 and 2. 5 students score 60%, 2 students score 80%. Therefore, the number of students that will score above 50% are 5 plus 2, which is equal to 7. Hence, number of students that score above 50% is equal to 7 over 30. That is the number of required outcome, which is 5 plus 2 over number of possible outcome, that is total number of students, is equal to 7 over 30. So the answer here is 7 over 30 from our experimental outcome. Now, I want us to consider the last question that said, how many students, what is the probability that the student will now score below 60%? That is, below 60%. The number of students that will score, number of students that score below 60% are 11 plus 8 plus 4, which will give us 23, which is the required outcome. That's one of the questions. Now, we want to find the number of possible outcomes. Remember when I told you that the number of possible outcomes is the total number of students that took this mathematics test. Therefore, number of the students that score below 60% is equal to 23 over 30. That's the probability of us choosing a student that score below 60%. Is an example of an experimental outcome. And I told you earlier on that experimental outcome is the number of trial, that is experiment that is being carried out. I am confident that you understood the experimental outcome of this probability. I would like us to do these few evaluations that will be shown on your board. And if you still have any shady mindset, I would like you to rewind back to have more understanding. Thank you. Wow, I'm happy because you got the answer correctly. I'd like us to still go further by knowing the meaning of random experiments. We've knew the meaning of experimental outcome. It's another terminology we have to know, random experiment. What is random experiment? Random experiment means measure put on the occurrence of random phenomenon, which means it is usually given as a fraction. That is, it is the measure put on the occurrence of random phenomenon. It is usually given. It is usually given in form of a fraction. Let us consider this example. This example is very interesting. This is one of the practical probability that we're going to look. If a die is cast, what is the probability of getting an even number and an odd number? Now, if a die is cast, what is the probability of getting an even number, which is 1, 2, an odd number? We all know the meaning of die means the Ludo dice. That's the meaning of die. Then, what is the probability of us getting an even number when a die, one die, a cast? That's from the question. A die. If a die, we have to consider our understanding, that is the measure put on the occurrence, which will be given in form of what? A fraction. So, what is our required outcome? Our required outcome is the even number. So if a die is cast, we all know the shape of a die, which is form of a cube, which has 6 faces. It has 6 faces that have different numbers, from 1 to 6. Now, the first thing we need to know is the sample space. The meaning of sample space is the list of possible outcomes. That's the meaning of sample space. The list of possible outcomes of a given experiment. That is, what are the possible outcomes? What are the possible results from our experiment? If we cast a die, if we roll a die, it will show 1, it will show 2, it will show 3, it will show 4, it will show 5, and it will show 6. So the sample space is equal to 1, 2, 3, 4, 5, 6. This is the sample space. The possible outcome that will be produced is this. Now, the required outcome was the question they are now asking us. You can see we define experimental outcome as the number of required outcome over number of possible outcome. It's very simple. So therefore, let us calculate this answer. What is the probability of us getting an even number? What is the even number in this aspect? The probability of the even number here is equal to 2, 4, and 6. The odd number in this aspect is 1, 3, and 5. So we have the even number. This is the number of required outcome. This is the number of required outcome for the odd number. This is the number of required outcome for the even number. So the question is very easy. Let us apply our formula, because the probability of us casting a die has given us a sample space of this. So the answer to this question is this. The answer to this question, we have the sample space to be equal to 1, 2, 3, 4, 5, 6. While the probability of getting even number is equal to how many number do we get? That's 3. It's going to be 3. That's the number of the even number. That is the number of the required outcome over number of possible outcome. 1, 2, 3, 4, 5, 6, which is 6. 3 here 1, 3 here 2. So the answer is 1 over 2. The probability of us getting an even number is 1 over 2. Is 1 over 2. Also, the probability of us, which is number 1, the probability of getting odd number is equal to 3 over 6. 3 here 1, 3 here 2, which is equal to 1 over 2. Also, the probability of us getting an odd number is also 3 over 2, because the number of the required outcome we got is 1, 2, 3. That is 1, 3, 5. Then the even number is 2, 4, 6, which are 3. So 3 over 6, which is 3 here 1, 3 here 2, which is half. So both the questions is half. That's the probability of us getting even number is half. The probability of us getting odd number is half. With this, I would like you to do few evaluation, because I know you understood the meaning of what is called random experiment. Random experiment. Let us check these few questions on the board. Wow, you're welcome. I know you understood this random experiment. Let us proceed by moving forward to another terminology called sample space. What is sample space? Sample space is the list of possible outcomes of a given experiment. Is the list of possible outcomes in a given experiment. Example, suppose we toss a balanced die once. Suppose we roll a balanced die once. We tossed a die once. What is the sample space? Suppose tossed a die once. Toss a die once. What is the probability? What is the probability in terms of its sample space? Therefore, the sample space of when we toss a die once is equal to 1, 2, 3, 4, 5, 6. This is the sample space we are going to get. That's the result. From my definition, I told you that this is the list of possible. This is the list of possible. Those are the things that we're going to get. The list of things that we're going to get after which we toss a die. We can get 1, a Ludo die. We can get 2. We can get 3. We can get 4. We can get 5. And we can get 6. So tossing a die once, that's the possible outcome. That's the possible outcome. With this, I know you are convinced about this sample space. I would like us to move forward by considering another terminology called event space. Event space. We want to consider another terminology in this probability called event space. Event space. Event space. Event space. I want to give us an example of event space. An even number is a subset part of sample space chosen by a given rule. For example, when we solve our even number earlier on, we have 2, 4, 6 is a subset of the sample space. Sample space 1, 2, 3, 4, 5, 6. So an even number can be found in the sample space. That's the meaning of an event space. Now let us consider probability, which is our last terminology. Probability, which is another terminology we center on in this topic. Probability, this is the measure of results. This is the measure of result or outcome of expectation. This is the measure of result or outcome of expectation. Probability can also be defined as a measure of chance of event happening. As the measure of chance of event happening. That's the definition of probability. I would like us to still have few knowledge about probability. When they say an event is sure, that shows in probability it represents 1. When they say an event it is not possible, the meaning of probability is 0. So if an event is impossible, it means it's 0. But when an event is going to happen, it means the probability is 1. We all know every Christian will go to church on Sunday. So the probability of every Christian going to church on Sunday, that is Christian worship on Sunday, the probability is possible, which is 1. The probability that all Muslims will worship on Friday, the event is possible. So the probability of an event happening, the chance of an occurrence, which is the definition of probability, is going to happen. So therefore, probability is just telling us the chance of an event happening. The chance of an event happening. So if it's not going to happen, it means impossible, which is lies in 0. If it's going to happen, it's going to be 1. I would like us to move forward by concluding this topic today, probability 1, which has really explained the different terminology, the different experimental outcomes, the event space, the sample space, event space that can give us the clue to different knowledge, to different questions ahead of us. Thank you and God bless you. If you still have any shady mindset, I would like you to rewind back so as to have more knowledge about this probability 1. Thank you.